Energy efficiency. The energy efficiency of a power supply is a measure of how much electricity from the wall outlet is actually converted into usable power for the computer, and how much is wasted as heat. Since no electrical device is perfect, some energy is always lost during the conversion from high-voltage alternating current to low-voltage direct current. For a technician, understanding efficiency is the key to reducing electricity bills, lowering system temperatures, and ensuring the longevity of internal components. The 80+ certification system. To help consumers and technicians identify high-quality units, the industry uses a standardized voluntary program called 80+. This certification guarantees that a power supply is at least 80% efficient at various load levels, specifically at 20%, 50%, and 100% of its rated capacity. If a power supply pulls 100 watts from the wall, but only provides 70 watts to the computer, it is only 70% efficient and would fail this test. As the quality of the internal components like capacitors and transformers increases, the efficiency rating goes up. The program is broken down into several levels that are easy to remember by their metal names. 1. 80+ bronze. This is the entry-level standard for most professional builds. It provides basic efficiency and is much better than no-name power supplies that often have very poor conversion rates. 2. 80+ silver and gold. Gold is currently the sweet spot for many modern gaming and office computers. It offers high efficiency and better heat management without a massive price jump. 3. 80+ platinum and titanium. These are the highest tiers available. Titanium is the only level that also tests for efficiency at a very low 10% load. These units are typically found in high-end workstations and massive data centers, where every watt saved translates into thousands of dollars in energy savings over time. Why efficiency matters: the heat factor. The missing energy that is not converted into power for your components does not just disappear. It is transformed into heat. If you have a 700-watt power supply that is only 70% efficient, it will generate much more internal heat than a 700-watt unit that is 90% efficient. This heat is the enemy of electronics. It forces the power supply fan to spin faster and louder to keep the unit cool, and it can bleed into the rest of the computer case, raising the temperature of the CPU and graphics card. A more efficient power supply runs cooler, stays quieter, and usually lasts many years longer because the internal parts are not being constantly cooked by wasted electricity. Calculating energy waste. Technicians can calculate exactly how much power is being pulled from the wall by dividing the system's power draw by the efficiency rating. If a computer needs 400 watts to run and the power supply is 80% efficient, you take 400 and divide it by 0.80. The result is 500 watts. This means the power supply is pulling 500 watts from the wall, but wasting 100 watts as heat. If you swap that unit for a 90% efficient gold-rated model, you divide 400 by 0.90, which equals about 444 watts. By simply changing the power supply, you have reduced the building's energy consumption by 56 watts without changing any other parts in the computer. The efficiency curve. It is important to note that power supplies are not equally efficient at all times. Most units are at their absolute most efficient when they are under a 50% load. If you have a 1,000-watt power supply, but your computer only uses 100 watts, the efficiency will actually be quite poor because the unit isn't working hard enough to reach its optimal state. This is why a technician should not just buy the biggest power supply possible. The goal is to match the power supply's wattage to the system's needs so that the average power draw sits somewhere between 40 and 60% of the unit's total capacity. This ensures the user gets the maximum benefit from their 80+ rating.